All right. I said I wouldn't talk about it, and then I didn't.
I woke up Sunday morning like 9 after work or whatever and started reading some predictions or whatever.
Detroit's actually,
And then they said did the Browns put up a fight, but then the Steelers would come.
All right, guys. So, questions? Yes.
I'm just having trouble tracking tangents and cotangents. I like number 30 and 5.4.
Okay.
Really simple.
Now the main difference between tangent and sine, for example, what are a couple of differences between tangent and sine? Yeah, tangents were vertical. Sine's period is 2 pi, tangents is pi. And as far as what you, starting point, as far as what you look for when you make your list, your phase shift and so forth, that still applies. But what does not apply really for tangent? Amplitude. But that number that's in front still tells you what it does a quarter of the way through. So that's how you let that help you. So which one again? 30? The cotangent. This one here, right? So what does cotangent normally look like? Let's do a quick little, where's the first little asymptote?
what is what?
Cotangent, what does it normally look like?
It usually goes through.
Like a negative x cube.
So tangent goes from negative pi over 2 to pi over 2. Cotangent goes from
0 to
0 to pi.
So it goes through something. Pi,
That is awesome.
Something, yes.
pi over 2.
And of course it looks the reverse of tangent, right?
Yeah.
So it's like that. And at the quarter points, this is going to be 1 normally, and that's going to be negative 1. Alright. So that's cotangent, what it normally looks like. So it's not a bad idea to have that picture somewhere next to you when you're doing this problem. So now, the very first thing you can see, so there's no real amplitude, but it's still going to be, the quarter points are still going to be 1 and negative 1. However you want to identify that for yourself. It's not really an amplitude. What's the period going to be now? Yeah, what is it normally? That's right, 2 over 2 is good. Normally it's pi. Now I'm going to divide it by pi over 2, because that's the k. That's the multiplier. And that comes out to be 2. Right? That's a problem from there to there that my calculus 2 students can't do. It really makes me cry. Pi divided by pi over 2 is pi times 2 over pi, which is just 2. Let me see, phase shift, any phase shift? No. Okay. So, you can go through the steps. It's going to start pi over 2 over x equals 0, because it normally starts at 0. So it's still going to start at 0, because it hasn't been shifted left or right. Mm-hmm. And it's going to end, normally it ends at pi. Now it's going to end at 2, which makes sense since the period is 2. And again, you can show that or not. I mean, that's totally up to you. Sometimes you need it, sometimes you don't. You definitely need it for tangent, because it doesn't start at 0. Right? It changes according to both the compressions and the shifting. It messes it up a lot more than if I started at 0. Okay, cool. So now we know it's still at 0. And now it's going to end at 2. So the midway point's 1. The quarter points are... So what do I do with the period? Cut it in fourths.
Half.
So now the quarter, and of course you can just tell, half of 1.
1 half.
Yeah.
1 half. Oh, 3/4.
Right, not 3/4, 3/2. I get it simple. And the amplitude, but really where it's going to be is still 1 and negative 1. So at the quarter points, it's still going to go 1 and negative 1. Now, I want to make this point because I saw this in the homework. You don't actually plug points in. You don't make a little table of values. You shouldn't need to. You can if you want to check it. But what's most important here is what it normally does at these points. It does still at these new points, these shifted points. So normally at the first quarter point, it's at 1. Well, it's going to be at 1 still. If that would have been at 3, it would have been at 3. If it would have been negative 3, it would have down there. And then in the middle, it goes to 0. And over there, it's on the reverse of that guy. And then it's just approaching the asymptote to get it. Cool. And if they would have said +2 or something, yeah, that would have just gone up to 2. And then, you can shift these 3 major important points. Just shift them up. Is that cool? Yeah. So it's still, you're still looking at all the same things. It's just the amplitude doesn't really mean the same thing, but I still use it. I still use that number to help me. And the important thing is this, cutting it in force and just putting over top of this the shape. Because I saw in some of the homework that I graded, some people were just saying, okay, pi over 6, and then they plug pi over 6 in the sign, and they put it where it normally goes. But it wasn't sine of x, it was sine of x minus pi. It's been shifted. You can't... So I don't want you to make a table of values for this. Don't do that. Right? I don't care what... when you plug a 0.3 in where it goes, I just want to see those 4 major positions for any trig function.
Can we do a tangent one?
Yeah, sure. What do you got?
Or whatever you got.
Okay. I'm sorry. Let's see. 4 tangent. What, Jeff? 2 pi x minus pi over 6. That's horrific. I like it. So, at the quarter points, where's it going to be? What's the amplitude? 4. So it's not really the amplitude, but it's going to be 4, -4 at the quarter points. Whatever those quarter points end up being.
Yeah.
So if I can find out where my new cycle occurs, I just draw the cycle in. So whatever happens normally halfway through is still going to happen. Whatever happens 3/4 of the way through is still going to happen.
Yeah.
What about the phase shift? What do I have to do here? Yeah, if I take a 2 pi out, I get x minus
1/6.
1.
Third. Oh my god, that was so dumb.
That, no, it's still not quite right. I think I heard it 1/12. You guys are so not used to that. When you take a 2 out, you're dividing by 2. 1/6 divided by 2 is 1/12. If I took out a 1/2, it would become 1/3. Because the 2 would just come right out of the 6 then. So the phase shift is 1/12 to the right. Okay. That doesn't help me as much because this tangent normally. So let me see. What's the last thing to do? We're going period before we get to where it starts and ends.
2 pi.
2 pi.
No.
What's the period normally?
2.
2.
Pi, and I'm going to divide that by
1/2.
2 pi. So now it's going to be 1/2. Okay. Trust the math. Don't take guesses. So now, where does it start? Normally it starts at negative pi over 2. So now if I set this thing equal to that, so divide by 2 pi, the pi dies, I get x minus 1/12 equals 1/4 negative. Is that cool? Divide by 2 pi?
Mm-hmm.
Okay. And then I add 1/12, I get 1/12 minus 3/12, 1/6 negative. We stop there. Yes?
Yeah, I got confused.
Where?
The start, yeah.
Alright, so any trig function you can do this for. This is the one that you have to do this for. And you just set this interior. If I had just tangent x, it's going to start at negative pi over 2. That's going to be the first place where it's got the asymptote. So if I set whatever the interior is to that and solve for x, I can figure out, well, now what x value now makes it go here. What x value now makes that first asymptote occur? Bless you. So if I solve for x, I can figure out all the shifts kind of go through the algebra that I'm doing. All the shifts get applied, and I got to start there. So set whatever's inside the function equal to where it normally starts. Tells you where it now starts. Set it equal to where it normally ends.
This is where it now is.
That's crazy. So 2 pi x minus 112 equals pi over 2. So you get x minus 112 equals positive 1/2, 1/4. And now if you add 1/12 over, you get 3/12 plus 1/12, 4/12, which is 1/3. How far apart are these? Yes, good. If I just asked you on a test, how far apart are the numbers this and this, you should go, just subtract it in. You know, it shouldn't be a big mathematical problem. It's not. Right? It should not be a big deal for us. Okay. But of course the trig gets in our brains and we're like, oh, it's got to be something weird. No, just subtract the numbers. Alright, let's see. So now I know where it starts. Oh yeah, what if I, the period is 1/2, so if I cut that in fourths, 1/8, so I want to step by 1/8. Look at all those yummy denominators. That's too bad. So what I can do for myself, where these of course agree. Yeah, so if I make this negative 4/24 and I make this 3/24, now it would be a lot easier to step along.
Yeah.
You can totally do that. It's the same stupid number. I don't care. Maybe.
And then you don't need us to put it down to the reducing stuff. And when we graph it for you.
No, it's beautiful because then I can see your scale.
Okay.
So I can't complain about that.
All right.
Yeah.
I can try, but I won't. So I can't. Okay, so now I start at negative 1/6. Now if I take a step of, so negative 4/24. And every step I take, it can be 3/24. So the next step takes me to
1/24.
negative 1/24. Add 3.
2/24.
2/24. Add 3/24. 5/24. Add 3/24. And that's 1/3, which is where it's supposed to end. You see all the checks and balances there are in these problems.
Yeah.
And by the way, I mean, this is an ugly, ugly problem. I want you to realize. I feel like, holy shit, well, this is tangent with a lot of stuff going on, but it's really funny to me how you just do this, and it tells you exactly where you start. You do this, and it tells you exactly how much to step through. And the math behind these should make total sense. I just want to cut it into 4 parts. Yeah?
If you find the start point, can you just add a half to it, and then that would be your end point?
That would be your end point, and then cut them in half?
Yeah.
Sure. You don't have to do this.
No, I mean, you don't have to do the end.
No, yeah. These, as long as you find the start point for tangent, you're golden.
Once you have the period.
There's a lot of different ways to do this, because the math behind this is so simple. It really is. The math behind this is so simple. There's a lot of ways you can just do that math. This is the most in-your-face kind of way to do it. The most just crank it out kind of way to do it is this. You guys can adjust that however you want. In fact, that's true for all of freaking mathematics. The people that do really well at math are the ones that make math their own thing. They say, okay, that's the rule. All right, I'll use it this way. This is the way it makes sense to me. So what does tangent do at the first position?
It's asymptote.
Asymptote. And then there's asymptote at the end. And what's it do at the middle position? 0. And at the quarter points,
It's negative 1.
No, it's positive 4.
yeah, well, I got these two in reverse. So tangent, of course, normally looks like So normally it's negative first, right?
Yeah.
So it'll be the negative 4 and 4 at the quarter point. No, get out of there, Jeff. There it is. And then here, this one. Yeah. That is really wide this bad boy out. And we're going. We're there. We're done. Right? It's just got to connect again. So here it's got to approach that, go through here, go through there, and then approach that. please get more used to making your scale whatever the hell you need to make it fit. My scale, I should have made this smaller. I should have made it a little less wide. Oh well. But you can certainly think ahead what your scale should be so that it'll fit nicely. So I still get way too many things like this. And all this should go, well, blow that out. Wow. Right? Make your step 1/2 or 1/4 or whatever's going to make it make more sense. If my period comes out to be 1/24, holy crap, please, yeah. Take that thing out. Don't make everything happen there. Is that cool? Okay, good. Anything else from homework or the practice test or, yeah.
6.364.
Oh. Oh, 6.3. Okay, let's look at 6.2. 64. Oh, yeah, good. All right. So this is one I don't think I've talked about it in the lecture yet, have I? I had a couple people come to my office. That's one that, if nobody asked me in lecture, if nobody asked me this question, I get a little worried. So rain gutters to be constructed from a metal sheet of width 30 centimeters by bending up 1/3 of the sheet, blah, blah, blah. So all that stuff didn't matter because they gave you the picture. This is 10, 10, 10. What's up?
We've done one of this.
Did we do this one?
No.
I don't think we did this one. Show that the cross-sectional area is modeled by that function. Yeah, you almost don't even want to look at the answer yet. If you look at it, just forget about it. You just do the work you got to do. So, what kind of shapes are happening here that's useful for me?
Triangle.
Rectangle.
Good. There's a rectangle.
And there's triangle.
And there's triangles. So there's this rectangle here. And then there's these triangles on the sides. And those triangles are going to be symmetrical because they're both made with the same angle. Is that cool? So whatever is true for one of them is true for the other. So if I can figure out the area of one of these triangles and the area of this rectangle, add them together, I'm done. Yep. All right, so what do I need for the area of that triangle, first off?
Theta.
No, I don't need theta. They don't tell me the angle. I can't figure the angle out. Too damn bad for me. I want it to be a function of theta so I can figure out what angle would make it the biggest area.
You need to find the height.
Good. So I need to find the height or the base, however you want to look at it, and this is here, right? I need to find those two measurements. And that's not bad, right? Well, considering my angle is here, where is it inside my triangle?
There. Up top.
Well,
Yeah, it's going to be here, right?
Yeah.
And of course, here's my right angle here. Okay, so this piece, as far as I'm concerned, that would be X, and this is going to be Y. Right? You could even draw the triangle out here if you want to, and the angle's already in it.
we're about to set the sign of.
So this, Y would be
10 sine theta.
10 sine theta. Let me stop right there. You guys see that?
Yeah.
Yes.
Okay. And then this X is going to be.
10.
And what I'm about to say is not really true. Not exactly true, but it's really close to true. This is why I love looking at this as sine like y, cosine like x, because sine is like a percentage of the hypotenuse in the y direction. And sine being a percentage makes total sense, because sine can only be between 0 and 1, and the negative just tells me I'm on the other side. You guys kind of with me? Mm-hmm. So again, if you get in any physics, looking at it like that is going to make your job so much easier the first month and then past that. Because you got a lot of vectors and adding vectors, and all you got to do is get the x and y piece of that one, and the x and y piece of the other one, and then add the x's and y's together. Ooh, right? Makes it very easy if you look at it like that. And so what's the area of that triangle? Yeah, 1/2. the base times the height.
Or you can just get rid of the 1/2 since you have two.
Beautiful, I love it. So since I have two triangles, so the area of the two triangles will be 100 sine theta, cosine theta, and if you look at your expression, that looks good so far. And
Two?
one triangle, two triangles.
Oh.
So the area of this one is going to be 1/2 this. Add that one in, I get a full one of these. Now what area do I still have to do? And then I've already done what I need to do for
The
it?
rectangle.
The rectangle. So the rectangle is 10 times
10.
y. Here. Can't be 10 times 10. You got slanted. The true height is 10 sine theta. So then the area of the rectangle is
100 sine theta.
100 sine theta. So then the area of the whole shape will be that plus that, which thankfully is the expression they have. Right? You guys with me? Yes?
How did you get 100 cents?
Oh, just multiply. 10 times 10 is 100. Sine times cosine is sine times cosine. Is that really, or are you curious about where that came from?
Sorry about it.
You got that where that came from? Okay. Cool. And then part B just says graph it, and part C says find the largest cross-sectional area. So you know how far to bend that piece, right? So you bend it so that it's 10, 10, 10, and then you go, well, how far do I want to bend it so this has the most area in the middle? So it can hold the most stuff. It makes sense. So in real life, when you're trying to engineer something, you get a lot of things that are based on angles, functions of angles, because the more you bend it, that's going to have an effect on these other things, right?
How do you graph it?
On the calculator.
Okay.
Yeah, just say put it in the calculator. I'm not going to make you do this by hand, right? Like you could, but I'm not going to make you. That's silly. So let me do this in case you guys have tried the practice test out. Here are the answers. One of them I want to finish up on the board. Let's run out of room. So number 7, that was the one that referred to a couple problems out of the book. Number 30, I didn't finish. Let me see, what page was that? Page 485, I think it was. Oh yeah, number 30. Just to warn you guys, I mean, this kind of problem I like, right? So you know it's going to be on the test, something like this. And we saw a problem like that on that Trig review handout that we did a while back. It was the Mount Doom problem? Oh, yeah. And they walked a little further. Yeah. Where you guys suddenly became ominous. So number 30 is the one with the plane up here. My beautiful plane. Oh yeah, now you can see the beautiful boats. So there we go. Boat there. Boat there. Yeah. My Navy's not going to win this battle. Angles of depression to two ships, 40 and 52 degrees. So this guy here is 52. And this guy here is 40. And you have to figure out how far the ships are apart. I think I started drawing it Yeah, I just kept all the triangles up here since the angles are in here. Remember, your elevation and your depression angles are always relative to the horizontal. So be careful about where you just stick that angle. It's going to make everything turn around if you put it in the wrong place. So one triangle I've got is this guy here. So I've got a triangle like this. And then another triangle I've got is this guy here. So I've got this dude here, 40 degrees. And I labeled, you can label how the hell you want to, but I labeled this guy X1 for some reason. I just needed X. And then this one was D. That's the distance I really want to figure out. So this should feel very familiar. I mean, a lot of problems sort of look the same. And this one almost looks like the Mount Doom problem in reverse. Instead of being on the ground, I'm in the air, but I still have these different distances that lead to different angles when I look at the two places. The other one, the hobbits were looking up at the top of Mount Doom, and a little bit later it was a bigger angle to get up there. It's exactly the same situation, just kind of like reversed. So this would be X, and what would this be?
X plus D.
X plus D. And of course, in both situations, this here is, yeah, they tell us the plane is flying elevation of 35,000 feet. So both of those, of course, are the same distance. So now we have everything we need to figure out. And of course, I'm going to need, since I have two unknowns up here, system of equations. I'm going to need two equations. And the variable I care about is D. So this first one, what can I set up?
Tan of 52.
Yeah, tan of 52.
Equals 35 over X.
Beautiful. And then a very similar thing for over there.
Tan of 20. 35 over X plus D.
All right, let me stop there. That should be remarkably easy at this point, right? Just figuring out, based on what ratio, what sides I know, figure out which trig function has those in the ratios it sets up. So tangent sets up a ratio between the side I know and the side I want to know, and both. Kick ass. Okay, don't always think it's going to be tangent. If I gave you this distance here somehow, like there was a rope or something, right? Got tangled up in the ships or something, who knows? Then it would be a different trig function used here, but it's the exact same idea, right? So between these two, I want to figure out D. So I can do just like we did on the Mountain Dew problem. I can simplify both of them a little bit. I'm going to solve this one for X, and I'm going to plug that bad boy in here, right? So you guys take a minute and try to figure that out, and then we'll do it together, see if we all get the same answer. Oh, yeah. Yeah.
So that's not right.
No, yeah, it should be square.
Okay. I'm curious.
All right.
Making sure.
Yeah, I'll announce it here in a second. Yeah. Yeah, exactly. I'm going to say it here, but checking my work so hard. Huh?
It's not checking your work. It's
No, it
checking
is.
our
It's a good
work
idea.
to see that whether we were right.
What's up? Why not? It's like me not liking corn or eggs. Why not? Tastes bad. We won't. It just tastes bad. It's a bad taste. This is kind of, well, you know, I'm definitely biased. But I mean, we haven't gotten that far away from the idea. You can still see the idea of trig functions being ratios of sides of triangles. But at the end of chapter 7, I'm going to remind you about trig functions are just ratios of sides of triangles. That's all they are, aren't they? That's it. That's all they are. And by the end of chapter 7, you're like, holy shit, we've done all this stuff with that. It's crazy. So this isn't that far removed. You can still see the right triangles. You can still look at the sides. And now the math's going to go through it now. So I just take that. And this is one way to do this. Plug it in there. Subtract it. Is that cool? So just plug that there, subtract it over, and now just plug that in the calculator, make sure that you're in degrees, right? So what do you guys get for the distance?
14,366.
14,366.
0.37.
0.36?
7.
7? Oh, feet. Okay. Not too bad. Right? Now, on the answer key, real quick. 3a, area should be 1/2 r squared. So I didn't square the 35. So this 35 should be squared. So whatever number you get from that operation will be your answer.
2,245.
3a on the answer key. The area is 1/2 r squared. I just left the square off of 35. So square 35 and throw it in there and see what it comes out to be. Cool.
2,244.93.
Okay. Yes.
Can you go over number 10 on the practice?
Oh yeah. Okay. Good. I like that set of functions. This is nothing special to this section, by the way. Anytime you learn a new function, anytime you have any function, I don't care, anytime you have any equation, you can make y1 equal one side, y2 equal the other side, graph it and see where they meet. Period. Sometimes it's impossible to solve something by hand. This is basically that situation. It's pretty much impossible to solve this one by hand. So while this thing's warming up, anybody have the next place you want to go?
I just have a couple questions regarding, where'd they go? To C and D. When we're messing with negatives, we don't want to bother trying to convert them if you're asking for a certain degree.
No, when I say convert the given thing to degrees or radians, just convert that straight. I didn't ask for a coterminal angle. I'm not asking for a reference angle. I just want to know what that thing looks like in the other unit.
Okay.
Is that cool?
Now, the other question is...
It's a good question, though, because I always get somebody doing something extra.
The other question is, you have some of these in the pi rad formula. Is it okay if we have them in decimals or not?
Oh, for answers?
Yes.
Like you mean like for 2D or something like that?
Yeah. Like you have -3/10 pi, but say it's just an example of 1.7 pi rad.
Yeah,
Okay, is it acceptable since
for
you didn't say exactly.
just for angles, you normally try to maintain the for radians. You normally try to maintain the multiple of pi idea.
Okay.
But I mean, if you showed me that and then made it to a decimal, okay, great, right? So as long as I see your setup work, you'll be okay there. Just in general, you want to try to keep the pi in there if it's an angle. All right. Dude. Little tiny little. Wow. Okay. So let's see. What was this thing? Cosine of 2x. And I want to see where's that equal inverse 3/4 inverse tangent of x. And the interval is 0 to 2 pi, so I might as well go ahead and make my window 0. And here's what's really cool about this. I don't know if you guys have noticed this. I can just put 2 pi. And it knows what the hell that is. I don't know why my scale's all freaky. Am I in some weird mode? No. I don't want my scale to be that. I don't want my scale. It doesn't matter. Let's make it 0.5. And considering that one of these is cosine of 2x, what's the highest and lowest that could possibly be? What's the highest and lowest cosine of anything could be? Negative 1 to 1. Yeah, so don't freak out about the 2x inside. That just pushes it in, right? Or cosine 2x will make the period a little less. It doesn't make that go up, right? Okay. So then maybe I want to make my y min and y max negative 1.5 and 1. Just to zoom in a little bit. So let's see what this looks like. Alright, so here's my cosine. Alright, so now I can see now. Interesting things happen out there. So let's see a little bit further out. Let's see, let's look at 7 maybe. Let's look up to 1.5. Okay, here we go. So there's definitely at least 3 answers to this thing. You can see there's definitely 1, there's 2, and then on the other side it goes in and out, right? Entrance, exit wound. And then over there, it looks like it probably does what on the last hump, dude?
It feels right above it.
Yeah, it might touch it. It looks like it probably goes right above it. I could zoom in and take a look. If you zoom in and take a look, it does go above it. It doesn't touch. So there's no answer out here. There's 3 answers in there. And how do you find each of them? Yeah, do the intersection. I'll do one real quick. And you can zoom in on this to make it easier. Let's do that. So I zoom in, zoom box. Enter for one corner. Enter for the other corner. And then I can really see my 2 intersections. That was fast. Alright. So now I can do my intersect. Do the intersect and then just put it right on top. The beautiful thing about intersect is it moves itself. First curve, enter. It moves to the second curve, enter. You're already at your guess, enter. So there's one answer. 2.96 roughly. Which problem was that?
Number 10.
Yay! So you can find the other one, and the first one was nice. You could see it really well from the way the window was in the first place. So you know you're going to have a problem, something like that. You guys doing all right?
Can you go back just to the Y window? What equals window? Okay. You just want to make sure you get that right.
If you have your calculator in the wrong mode and you go to graph, your graph could look remarkably weird.
It's just a
They usually like straight line.
Shit going on.
Yeah, they usually look like a straight line.
Yeah. Because your step is too big. So, or in that case, it'd be too small. Yeah, good. Okay. So, any other questions on that one, or what's up?
Is this number 9 on the practice test?
Yeah.
You showed it as a negative tangent. Is the graph correct? Or am I wrong? 'Cause that looks like it's a positive tangent.
Oh, yeah. This should be, I did like a cotangent.
Yeah.
Yeah.
Yeah, should that graph be flipped?
Yeah, it should just be flipped over. Good. Oh, yeah. Okay. I was going to do this whole little thing at first quarter point, -3 times what it normally is, and then I just forgot. And then I just put it at -3. So whatever that number is in front of the tangent or the cotangent, you multiply it by what it normally is at that point. So normally it's -1 at the point, so now it should be at 3. Right, so that picture should look, let's see. Basically, instead of it being like this, one, instead of being like, wow, like this, it should be like this here. Should be the reverse of what tangent normally does. Yeah.
Can you do a scroll?
Oh, you know, I want to say something. How did you guys do? What was that problem? Was it on the quiz or something? If I gave you this problem, somewhere there was this problem here. I won't get to your problem.
Oh, that one.
Where was that at?
It's on 4A, I think, or 4.
Yeah, 25 over 24 to be right for the secant. How did you guys do that problem? Did you do it the way I did it?
Created a triangle.
You created a triangle. Kick ass. Because you would make a triangle that has secant of theta like this, right? Now that triangle is not necessarily the real triangle, and maybe there was no triangle that led to this. But that is a representative triangle that shows me what this situation could be, and it gets me everything else that I need. So there didn't have to be a triangle that this came from. It could have been 50 and 48. It could have been any multiple of those, right? This is just always going to be lowest terms. And then, so what's this angle then? I like it, but be more specific. Good. So it's the inverse secant 25 over 24, right? That's what that angle is. So sine that comes from this, sine of theta, you can figure it out by doing the Pythagorean theorem and all kind of stuff, right? But what you're really doing is sine of inverse secant of 25 24ths. So here's where your question comes in. That's why when I'm given this kind of a problem, I can draw the triangle, because it really is this kind of problem. It's just shown in a different way. So if I do this work 25, where's 24 here?
Bottom.
Good. So that's going to be 7. Yeah, however you want to do it. You need to put the 7s on the end. You can identify it as negative at the beginning. I don't care.
Oh, yeah. Quadrant 3 or quadrant 4, it's -7.
Good. Sure. So, and one way I do it is sometimes I'll put the negative on the triangle itself. Or you just leave the triangle alone, get all your values, and then just come back in and go, okay, what's negative in this quadrant? Bam, bam, make them negative. Right, so I would do the work, sine of theta would be what?
7 over 25.
Yeah, 7 over 25, and then later I come in and go, oh yeah, it's supposed to be negative in that quadrant. Or you can label your triangle as having negative sides. It's just a representation anyway, right? Nobody can argue with you. You're like, it doesn't exist. Leave me alone. You can have a negative side. Nah. So, your real question was number 12A, right?
Yeah.
So 12a says, what's the sign of inverse secant of 3? So the very first thing I can do is,
3/1.
yeah, this is going to be 3/1, make a little triangle that represents this angle. It's the angle whose secant is 3/1, so where's 3 go?
Top, hypotenuse,
Hypotenuse, and 1.
cosine.
Get the other side, you can figure out what sine is. Cool. This thing happens so often, you have no idea. In calculus, and Calc 1, Calc 2, and this class. So it's really good to get this down now and just make it a basic skill. Think. Make it something you can do, no problem. Yeah.
The first symbols are only quadrant, right?
Beautiful. Exactly. So when I ask for a reference angle and you say 2 pi over 3 or something, that's not right. Yeah. It's got to be an angle that's in quadrant 1. That's why at the very beginning I said you only had to memorize quadrant 1 stuff. Because you can always get a reference angle back to there. Good.
And it needs to be in degrees.
Doesn't matter. It could be degrees, radians. You can say pi over 3 reference angle. You can say 60-degree reference angle. Doesn't matter. They're both names for the same angle. Well, where's that come in hand? Where do you have to be careful about that? Give me a situation where you got to be careful about radians versus degrees. What about the calculator?
Using the trig values.
Yeah, you want to make sure you're in the right mode in general. Cool. But what's a situation where you got to be careful?
Areas of sectors and stuff.
I love it. Areas of sectors.
Sector lengths.
Yeah, the arc length.
Or arc length.
You have to be, the angle has to be in radians, right? So if I ask you what's the arc length of this here, what's the arc length there? You can't just say S equals, and I got to give you the radius. So let's make the radius 4. So you can't just say S equals 4 times 17. No. Because theta is out by itself. I really want this, I don't know if you guys really get this. When theta is inside a trig function, it almost doesn't matter how I reference the angle. The trig function doesn't care what the hell you call it. It just says call it whatever, and I'll figure out what the sine of it is. So if I said sine of 17 degrees, it's fine with that. If I said sine of, what is this in radians? How do you convert that to radians?
17 divided by 180, it's
Yeah, whatever the hell that is, I love it.
0.0945.
So if I said sine is 17 pi over 180, it would be cool with it as long as my calculator was in the right mode,
Which is
right?
radians, right?
But when the angle is out by itself, it's its own thing. It's trying to represent the real world. And the only one of these options that represents the real world is radians. Degrees don't represent the real world. They don't. We've kind of overlaid the real world with our idea of 360 little pieces of a circle, and they work for us as humans, but they don't work for measurements. They don't. So this has to be in radians when the angle's out by itself. It has to be in radians for sure. There's no option. So to do this, you'd have to do S equals 4 times
17
this
pi.
bad boy here. And now here is definitely where it's no longer just an angle, it's now a length. So you can totally make that into a decimal, no problem. Okay.
Tell us how many decimals to go to on the test.
If I don't, 3 is normally a good option, 2 or 3. That's fine.
There you go.
I normally don't, because I normally don't remember.
Cool. Done.
I just know what I want. Realize what I want. That's all you gotta do. Right? It's like being in a relationship. You should know what I want.
This was the woman side of the relationship.
What's that?
So this was the woman side of the relationship.
This is true. Well, men are pretty basic.
Wow, okay.
We want some alone time. Yes. You good?
It's gonna be fun.
I think the test is tomorrow and not on Wednesday.
As always, if you're ready for the test, you don't have to stick around. See some of you guys kind of looking at
If
me.
I did the practice test
Yeah.
and I got all
Question number 7, or number 7A is how did you go about actually like converting it and stuff? Because I'm getting different answers than that.
Converting it to what?
Well, I know, okay, great. 1 kilometer